This is TWiT.
Now, did you know that late last year, space changed forever? That's right, we just didn't really hear about it. You see, New Horizons woke from hibernation on December 6, 2014, and it began its mission to study the dwarf planet Pluto. Now, imagine this. Here's a probe that was launched almost a decade ago. It's traveled 3 billion miles. It's 4 hours and 25 light minutes from Earth. It was launched before Pluto was demoted from planet status. In other words, they launched this thing when they thought they were going to be surveying a planet, and now it's a dwarf planet. On the way, it snapped pictures of Jupiter and the Jovian moons, and it has now started transmitting images back to Earth of Pluto. By May, because of the bandwidth restrictions, those images should surpass the resolution of what we're getting from Hubble Space Telescope. All this means that we're going to get a clearer view of the edge of our solar system than we ever have before. This is an amazing time to be interested in science. But strangely enough, this most noble of probes spent most of its life sleeping. You see, New Horizons was activated for just 2 months out of each year to check and calibrate the systems, but then it spent the rest of the year in deep hibernation with nothing more than a beacon to tell NASA that everything is okay. It would just ping back every once in a while and say, systems are good, systems are good, systems are good. Now, you might be asking yourself, well, why wouldn't you keep the probe on if it's going to be passing by such interesting features of space? And the honest answer is, aside from Jupiter, it really didn't encounter a whole lot. Space is really empty, especially once you get way, way out there. And they decided instead to save the probe for when it got to its target on the orbit of Pluto. Now, there is another problem. That problem is that power, as you get further and further away from the sun, is harder to come by. Spacecraft within the orbits of Mars and Earth can typically be powered by solar power, but once you get further out, solar power just isn't going to cut it. You can't generate enough with the solar panels that you would be able to carry on a probe of that size, and so they turn to nuclear. Specifically, they turn to RTGs. Those are radioisotope thermoelectric generators. Quite simply, it's radiation in a box that creates electrical energy. Now, RTGs, this one in particular, was a holdover from the Cassini missions. It was going to be a spare that they repurposed for New Horizons. It's 24 pounds of plutonium-238 oxide inside a container filled with the fuel formed into pellets that are clad in iridium and then encased in a graphite shell. RTGs work on the Peltier effect, and actually we covered the Peltier effect on Know-How, a show here on TWiT TV, where we showed people that by using a thermocouple, you could induce an electrical charge with a temperature differential, and that's exactly how RTGs work. As long as you have a hot side and a cool side, you can get electrical power. Well, in the case of an RTG that's going to be on a spacecraft, the hot side is going to be the plutonium-238, which will glow bright hot on its own accord. And the cold side is going to be the deep confines of space. Now, this particular RTG provided 250 watts of power at 30 volts at the time of launch. That dropped off at the rate of 5% for every 4 years of operation, which means that since the probe has been operating for almost 10 years, it's dropped about 12 or so percent, now providing something north of 220 watts of power. But here's the thing. They didn't actually save power by putting New Horizon into hibernation mode, because an RTG generates heat all the time. You can't shut it off. It's not a reactor with control rods. It just does it because of radioactive decay. That means that decay was going to happen whether or not they were extracting the power from it. No, the reason why they shut it off is because they wanted to save wear and tear on the spacecraft. They wanted to save it so that the components would last when they finally got into the orbit of Pluto. That's right, New Horizon was in hibernation because they needed the resources back on Earth more than they needed the resources on the spacecraft. Because as a spacecraft is in orbit, as it is in active journey towards its mission target, you're going to need a support team on Earth, and they didn't want to have to do that. Now, 220 watts is not actually enough to operate all the instruments on the New Horizon, so NASA has had to be very selective about which instruments are on at which time. And it's amazing the kind of science that they're going to be able to get. Everything from magnetic detectors to high-resolution cameras to a molecular sampler that will be able to breathe some of the high-altitude winds coming off of the dwarf planet Pluto. The technology is baffling. The mission is absolutely fantastic. But if you're a space geek, New Horizon is the New Horizon.